We are done with how to find the LCM HCF. We started with what is LCM HCF. Now we come to the place where we'll have to figure out when to take the LCM and HCF. This is the crux of most of the questions, right? You need to know when to use LCM, when to use HCF. With HCF, we'll start with the what is HCF, recap it quickly, and get a scenario to fit into this picture so that we understand when HCF is used. Right? Start with this example. What is the HCF of 36 and 48? In the what, when we were discussing the what, we listed down factors of 36 and 48. Here are those. Common factors of 36 and 48. The highest such common factor is 12. Now let me spin a story around it. Let's say there is a rice growing nation where farmers pack rice in 36 kg bags. There is a wheat growing nation where farmers pack rice in 48 kg bags. This is what they do always. You work for a supermarket chain, a retail chain, and you know 36 and 48 are not retail packet sizes. You want to repack it into smaller packet sizes. You pick a bag, your machine will completely pack it into smaller packet size, throw that bag away, and only then it can load the next one. Let's say that's a scenario. The only condition that you want to ensure is, if you have a 2 kg wheat packet in your shop, you will necessarily have a 2 kg rice packet, which means that the packet sizes of rice and wheat in your shop will always be the same. So what do? You know that you're going to break 36 into smaller parts, factorize it. You're going to make 48 into smaller parts, factorize it. You want those factors of rice and wheat to have the same value, which means you're going to pick the common factors. So what all will be the packet sizes of rice and wheat in your shop? It will be one of these 6 numbers. 1 kg, 2 kgs, 3 kgs, 4, 6 and 12. What is the weight of the heaviest packet? That's going to be 12 kgs. So this kind of a scenario is when we'll put HCF to use. What have we done? We have broken things down into smaller parts. So factorizing is breaking it into parts. Those kinds of questions is where you'll be using HCF. So just put it in words. HCF is used when we create sets out of things. We are breaking it into smaller parts, such that all sets have the same number of each of the things. So here we had rice and wheat packet sizes remaining the same. What's a Q? How do you figure this out? These are the keywords to keep in mind. Factorizing essentially means breaking it into smaller parts. So you'll use HCF anytime we're taking 2 large things and breaking them into smaller parts, making sure that the packet sizes, the weight sizes, the numbers in each of the parts is the same. Right? That's when an HCF question is used. Given a couple of examples, actually 3 examples. Right? The Elite Hotel has brought 27 treadmills and 18 ellipticals. The hotel divides them. This is the keyword. They're breaking it into smaller parts. Into several identical, this is the another keyword, into equal sized ones. Exercise room located throughout the hotel with no equipment left over, which means whatever is available is completely used up. These are usually 3 keywords. Probably you'll find synonymous expressions for these in any HCF question. So you're going to divide it into identical parts with nothing left over. Second example, Whitney has 25 decorative plates and 20 medals. She wants to display them in groups. So she's breaking it down, dividing it throughout our house with each with the same combination, identical sets with nothing left over. Right? Pause the video at the end of this third example that I'll give you. Read through these sentences once, understand how they work, get an idea so that you're able to use it in future questions. Third one, Anna is making necklaces. She has 120 red beads and 84 green. She wants to make all necklaces alike, identical, with no beads left over. Nothing is left over. How many green beads will it have? Right? Pause the video now. Read through these examples once more before you play it again. Let's move on to the second part, LCM. Here I'll take again an example. Let's find out the LCM of 2 and 3. Start by listing down factors of 2 and 3. Multiples of 2 and 3, 2, 4, 6, 8, so on and so forth. 3, 6, 9, 12, so on and so forth. Common multiples are 6, 12, 18, so on and so forth. The least common multiple is 6. So we've done all of these when we did what is the LCM and HCF. Now, where do we use it? Multiple essentially means something is done more than once. Here is event A that occurs with an interval of 2. Could be every 2 seconds, every 2 minutes, every second day. Event B that repeats with a periodicity of 3 or occurs with an interval of 3 days, 3 minutes, 3 seconds. We're trying to find out when do these things coincide. Let's take an example. John visits the gym every other day and he goes to a restaurant every third day. If today he went to the gym and visited the restaurant, when is the next the same two events will happen on the same day? So let's say today is day 0. Gym is going to happen on day 2, 4, 6. The restaurant is going to happen on day 0, which is today, day 3, day 6. So both these events happened 6th day from today, and it's going to occur every 6 days. So how do we figure out when to use LCM? When we find things repeating, when things happen more than once, then we will use LCM. The idea is to figure out when both these events, which repeat at different intervals, coincide. To find the point of coincidence is when LCM is used. This basically captures the keyword when actions repeat, when they happen multiple times, and you want to find out when they coincide is when an LCM will be used. Here are 3 examples with wordings to figure this out. David goes fishing every 5th day, and Brian goes fishing every 7th day. If David and Brian both went fishing today, how many days until they go fishing on the same day again? It happens every 5th day, happens every 7th day. We want to find a point of coincidence. The answer is going to be 35th day from now, which is the LCM of 5 and 7. Let's look at another example. Teresa is arranging black marbles in group of 13, right? And purple in groups of 15. She has the same number of black and purple. She's starting from the same point. If she has a box that contains n black, the box will contain n purple. This number is unchanged. What are the smallest number of marbles of each color that she could have? So this n is being divided into groups of 13, and this n is being divided into groups of 25. So you might be tempted to think that we are looking at a HCF question, but it's actually an LCM question. A times 13 should add up to this n, and B times 25 should add up to this n, because the starting point is she has the same number of each of these marbles. So some multiple of 13 should be equal to another multiple of 25. We're actually looking at the LCM of both these numbers. So 13 into 25. 325 is the least number of marbles that she should have started with. One more example. Pete and James are taking verbal tests. Pete gets 8 correct in each test, and James gets 9 correct in each test. At the end of the day, Pete and James have scored the same total marks. So if Pete took P test, he got P into 8 marks. If James took J test, he got J into 9 marks. These two are equal. So we're saying some multiple of 8 is equal to another multiple of 9. What's the least number of questions? It should be a 72. Right? So that should give you an idea about how the wordings of each of these questions is. Also given you a rapid fire quiz at the end of this. Essentially I've given you some 4 or 5 scenarios. What you need to pick out is you have to figure out, mark whether the question is a question to find out the LCM or the HCF. What else can you do to prepare for the test? Good question. You can always start by subscribing to this channel and signing up for the most comprehensive and affordable GMAT Quant course that's available online at gmat.visaco.com.